let's use what we know about conic sections and shifting to find the equation of some conic sections that aren't centered at the origin. So for our first example, let's find the equation of the ellipse that we get by shifting this ellipse so that its center is at 2, 1 instead of at the origin. And while we're at it, let's sketch this ellipse as well. So we're starting with x squared over 9 plus y squared over 4 equals 1. And we need to shift in the x direction by 2, right? Because originally the center of this ellipse that we start with is at 0, 0. We need to shift that over 2 so that the center moves to x coordinate 2. And in the y direction, we need to shift by 1 so that the y coordinate of the center moves from 0 to 1. Okay, now shifting in the x direction by 2, to achieve that in the equation, we need to replace x with x minus the shift. So replace x with x minus 2. And for the shift in the y direction, we need to replace y with y minus the shift, so y minus 1. And that gives us the equation x minus 2 squared over 9 plus y minus 1 squared over 4 equals 1. So there's our new equation. Be sure that you don't forget these parentheses here. Just by order of operations, if you omit those parentheses, your x won't be squared anymore, and that definitely would not produce an ellipse. Okay, so now let's graph this thing. So the center is, right, the center, we've shifted it so it's at 2, 1. So let's plot the center first. It's going to be right here at 2, 1. Okay, and after we've shifted the ellipse, right, this denominator under our x term, this is still the semi-major axis squared, so a squared, and under our y squared term here, this is still the semi-minor axis b squared. So since a squared is 9, that means a is 3, and b squared is 4, that means b is 2. So our semi-minor axis is going to be 2, our semi-major axis is going to be 3, and our major axis is in the x direction, so we need to move to the right and to the left 3 to get our vertices. But we're going to move to the right and the left from the center of the ellipse. So we need to go right 1, 2, 3, so there's one vertex, and left 1, 2, 3, there's the other vertex. And then we need to, from the center of the ellipse, we need to move up and down 2. So up 1, 2, there, and down 1, 2, there. And now we can sketch our ellipse. It's going to be something like this. And I've done a pretty bad job of keeping things symmetric, right? It looks like the distance to the right-hand vertex is less than the distance to the left-hand vertex, but that's just because I did a bad job of drawing this ellipse. All right, let's look at a few more examples of coming up with equations for conic sections using this shifting idea. So for this example, let's find the equation of a parabola whose focus is at 4, 2, and that has directrix y equals 0. So let's sketch this. So, right, if our directrix is y equals 0, that's the x-axis. And our focus is at 4, 2, so 1, 2, 3, 4, 1, 2, so here, that's our focus. And for the parabola, remember that our sort of template equation for the parabola, which is either 4ax equals y squared or 4 ay equals x squared, depending on which direction the parabola opens, both of these, the vertex is at the origin, right? So we need to know where is the vertex of this parabola that we're trying to find here, so that we know where to shift the origin to. And if you think about the geometry of a parabola, the vertex is always halfway between the directrix and the focus. So the vertex must be right here. So I'll label that V for vertex. Okay, so the vertex is at 4, 1. Okay. Now that we know where the vertex is, we can figure out the focal length of this parabola, which remember is the distance from the vertex to the focus, and that's 1 in this case. So we know that A equals 1. Because the focus is above the vertex, that means this parabola is going to open in the y direction. It's going to open up. And that means we need to use the version of the equation where x is squared and y isn't squared. So let's write down our unshifted equation first. So we need this version of the equation of a parabola, and a is 1, and so that means our equation is 4y equals x squared. But remember, this one has the vertex at the origin. That is 0, 0. So we need to get the vertex to the right place, we need to shift in the x direction 4, and in the y direction, we need to shift 1, it looks like. So in the x direction, that means we're going to replace x with x minus 4 in our equation. And for the y shift, we're going to replace y with y minus 1. Okay, so that gives us 4 times y, which we're changing to y minus 1, equals x squared, but we are replacing x with x minus 4. So there's the equation of our parabola. 4 times y minus 1 equals x minus 4 all squared. If we wanted to multiply this out, we could if we needed to for some reason, but let's leave it like this. Okay, another example. Let's find the equation of the ellipse with foci minus 2, 5 and minus 2, 3 that has major axis 4. So let's draw a picture of this situation so we kind of understand what our ellipse is looking like. Here's our coordinate system. The foci are at minus 2, 5, so 1, 2, 3, 4, 5. So there's one of the foci. And minus 2, 3. So there's the other focus. Why don't I move all of this down? Okay, our major axis is 4, but to know how to use that to sketch our ellipse, first we need to know what direction the major axis is. Since the foci are above and below each other, that means the major axis of this ellipse must be going up and down instead of left and right. And the center of the ellipse is always halfway between the foci. So that means the center of the ellipse is actually right here at minus 2, 4. Okay, now the major axis is 4, so that means the semi-major axis is 2, and that's also known as A. So from the center of this ellipse, we need to go up 2, 1, 2, and down 2, 1, 2. Okay, and these 2 points are vertices. This is a focus. That's the center. This is a focus. Okay. So we know our foci. We know our semi-major axis, right? Since the foci are 1 unit from the center, that means the focal distance, the focal radius of this ellipse is 1. And the focal radius, we called that C. Okay. The one thing that we don't know yet about this ellipse is how wide it is. In other words, its minor axis or semi-minor axis. And we've called that B. So we need to find B. Semi-minor axis. B, we still need to find that. But remember, for an ellipse, a squared equals b squared plus c squared. And we know 2 of these, so we can find the third. So a squared is 4 equals b squared plus c is 1, so c squared is 1. That means b squared is 3, and b is the square root of 3, which is about 1.7. So from the center, we need to go right 1.7 and left 1.7. Okay. And now finally we're ready to sketch our ellipse. We don't really need to sketch it, I guess, but we have all the information too, we might as well. And now that we have B and A, we can write the equation for this ellipse. First, let's write it unshifted. So the unshifted equation for the ellipse is this ellipse has its major axis in the in the y direction. So we need the version of the equation of an ellipse that has the major axis in the y direction. So that's x squared over b squared plus y squared over a squared equals 1. And now we can put in all the information we have so far. So we know b is root 3, so b squared is 3. So x squared over 3 plus y squared over a is 2, and so a squared is 4 equals 1. And remember, this version of this equation for an ellipse has the center at the origin. Okay, we need the center to be at, let's see, we had it in our picture here, minus 2 comma 4. We want center at minus 2 comma 4. So the shift that we need to do in the x direction, we need to move the center 2 units to the left for the x direction. So that's an x shift of minus 2. So we're going to replace x with x minus negative 2. That's x plus 2. And for the y direction shift, we need to shift from 0 to 4. So that's plus 4. So we're going to replace y with y minus 4 in our equation. So this gives us x plus 2 squared over 3 plus y minus 4 squared over 4 equals 1. And there's the equation of the ellipse. All right. Last example for now. Let's find the equation of a hyperbola whose foci are 6 comma minus 1 and 0 comma minus 1, and whose vertices are 5 comma minus 1 and 1 comma minus 1. Okay, let's sketch a graph of this mess first. Okay, so 6 comma minus 1, 1, 2, 3, 4, 5, 6, minus 1 there. So that's a focus. And 0 comma minus 1, so right there, that's a focus. Vertices are at 5 comma minus 1, so that's here. It's a vertex. And 1 comma minus 1 here. That's a vertex. Okay. And you can see the center of this hyperbola, right? The hyperbola is going to look something like this. You can see the center of this hyperbola is going to be right here, so halfway between the foci or halfway between the vertices. And that's going to be at, looks like 1, 2, 3, comma, minus 1. So that's the center. All right. So to write the equation of a hyperbola, remember there are two versions for the equation of a hyperbola. There's x squared over a squared minus y squared over b squared equals 1. And there's y squared over a squared minus x squared over b squared equals 1. And we want the one that opens horizontally, so the one that would have x intercepts, and that's the first one, so not the second one. All right, to write this equation, remember this equation has the center at the origin, so we will need to shift this. But first, let's figure out what a and b are. Now remember, a is in a hyperbola is the distance from the center to a vertex, and we know that. It looks like that's 2. But b, we don't know b, but we do know the focal distance for this hyperbola. That's the distance from the center to a focus, and that is 3. Yeah, 3. Okay, and in a hyperbola, a squared plus b squared equals c squared. And so since we know 2 of these, we can find the third. So a squared is 4 plus b squared equals c squared is 9. And so b squared is 5, and b is the square root of 5. Okay, so now we can write the unshifted equation for the hyperbola. Remember, that's up here. So we're going to use the version of the hyperbola that has the x with the plus in front. So x squared over a squared minus y squared over b squared equals 1. We know that a is 2, so a squared is 4 minus y squared over b squared is 5 equals 1. Okay, and remember this has the center at the origin. We need to shift this so that the center is at 3 comma minus 1. So when we shift in the x direction, we're going to shift 3. So we're going to replace x with x minus 3. And in the y direction, we're going to shift by minus 1. And so we're going to replace y with y minus negative 1, so y plus 1. Okay, that gives us x minus 3 squared over 4 minus y plus 1 squared over 5 equals 1. And so there's the equation for this hyperbola.